Hello students, this video is to help review for the first instructor exam for elementary statistics. Hopefully you studied on your own and took a look at the sample final that I gave out. This formatting might be a little different, but it's the same sample final. Here is the first question. They all have different point values. For example, the first question has 10 points per part, so for a total of 3, 6, 60 points. Pause the video, try this out, and then unpause it to see if you got it right. Okay, this question was asking about univariate data, a set of univariate data. These are grades received by students on a certain test. The first thing I wanted you to do is make a stem and leaf plot of these data. And on the stem and leaf plot, you identified all the stems and identified all the leaves. These are the values that are separated. One thing I just added in here was the key. In order to make a stem and leaf plot, an effective stem and leaf plot, the person that's looking at it needs to know what they're looking at. So this key identifies that each leaf is the ones place. The stems are either the tens place or the hundreds place, depending on which stem we're talking about. One thing that you should notice is that all of these leaves are in order: 40, 48, 48. The first number that I identified in this distribution was 48. And I put the number 8 as one of my leaves. Then later on I found a smaller number, which was 40. I had to put that 0 at the front. These leaves should be in numerical order, ascending, going up, numerical order. Okay, so that is letter A. For letter B, it asks you to obtain the 5-number summary of these data. In the calculator, you press Stat and Edit to put all the numbers in. There are 20 values here, and I can check that by checking my list that says L121 is a blank. This one is L1's 20. In other words, in the first list, it's the 20th value. This one would say L119. It is the 19th value in the list L1. Then you go to Stat Calc, one of our stats. You scroll down to the bottom of that readout that it gives you. It tells you that n is equal to 20. In other words, the sample is equal to 20 different values. And then it tells you the 5-number summary here: the minimum, quartile 1, the median, the quartile 3, and the maximum. As you can imagine, the next step for this is to asks us to construct a box plot. And I will show you that to you right now. Here's the box plot. The first step in drawing a box plot is not to draw the box. It's not to draw the whiskers. It's to draw a number line. This number line has to be evenly spaced. As you can see, I went down a little bit below the smallest value and a little bit higher than the largest value. That's how you're generally supposed to set them up, so that you have a little bit of space to work with. Above each one of the lines, I've listed the minimum, the maximum, the median, the quartiles for ease of reading, and then connect the middle three values with a box, and those outermost values get the whiskers. Box and whiskers, or box plot. For letter D, it was asking us to create a grouped data frequency distribution, otherwise known as just a frequency distribution. That's what we talked about in class. You might also know it as a frequency table, using class width 14. Class width 14 means there are 14 values within each class. So from 40 to 53, there's 14 values. Don't believe me? Count it on your fingers. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. That is 14 values. And then from 53, we go directly up to 54. Notice that there are no gaps here. There are no decimals, so we don't have to worry about 53.5 or 53.1, whatever it is. These classes also do not overlap. So from 40 to 53, if the value was 53, it would go here. If the value was 54, it would go in the next one. You can't have classes that overlap. This can't say 53, whereas this says 53 as well. You can have another situation, however, which looks like this. You could have the class widths listed as intervals instead. You can go from 40 to 54, from 54 to 68, as long as you're using the correct symbols. This symbol means that 40 is in this class, but 54 is not. We go all the way up to 54, we get to 53.999, etc., but we don't get to 54 because 54 has to be in this class. That's why it has the equal sign here and does not have the equal sign here. Using an inequality like this is called interval notation. You can use this notation or you can use this notation. It is up to you. That is letter D, and notice that these tallies correspond to these frequencies. There were 2 different values between 40 and 53, so we wrote that out as 2. There were 5 different values from 54 to 67. We wrote that out as 5, etc., and so forth. All right, for letter E, it asks us to draw a histogram to illustrate that distribution. So here's the histogram. Notice that the histogram has a space between this y-axis and the first bar. That is a required aspect of your histogram. There must be a space between the y-axis and the first bar. Notice that there are labels. Here's frequency and here's grades on test. Those labels must be here. Do not put the label class here. This cannot say class. This must say what the actual piece of data is. And in this case, this is the grades received by students. So that's why we said grade on tests here. It's okay for this one to say frequency because that's literally what it is. How many grades lay between 40 and 53? Well, there's 2 of them. That's the frequency. All right, so we have our histogram. Notice that all the bars are with 4 boxes. That is not a coincidence. They're all supposed to be the same width. All right, what is the shape of the distribution? Well, I'm going to use 2 things to identify shape. I'm going to use the box and whisker diagram that we constructed earlier and also the histogram. Both of these data displays look like they are left skewed. There's a longer tail to the left here and a gradual drop off here. So I would refer to these as left skewed. There are some pretty good reasons listed here. All right, for the next question, which is question number 2, it's the mean and standard deviation of zucchini grown in a local garden in inches. You were asked to compute the mean and standard deviation. Pause the video, try this out, see if you get it right. All right, this was another trip to the calculator for 1var stats. In this case, we're asked for the mean. In this case, we're doing sample mean because, of course, it says sample of lengths of zucchini. So we're using X bar. Notice that it does not give us the population mean here because in general, X bar, the sample mean, should approximate the actual mean. However, it is important to note that we are using the sample standard deviation here. We're using S sub X instead of the sigma because this is a sample. If this were a population, we would use the parameter, which is sigma sub X or simply sigma. There are similar questions that they might ask you on instructor exam number 1. Other questions that might be asked with a data set like this, you might be asked to find a z-score. You might be asked to find what percentile a certain value is at. You might be asked for the different measures of center or measures of spread. You need to know that the measures of center are mean, median, and mode, and the measures of spread are range, IQR, and standard deviation. At least those are the ones we talked about in class so far. You also might have to interpret a z-score. For example, if a z-score is 1.34, what does that indicate about the value? Well, if the z-score is positive 1.34, that means it's above the mean. Positive number means above the mean. And 1.34 represents the fact that it is 1.34 standard deviations away from the mean. In other words, whatever the standard deviation is, I think in this case it was like 2.4, something like that. Yeah, 2.45. It's 1.34 times that number away from the mean. All right. Incidentally, the question comes up all the time, what do we round to? And a very popular answer to that question is, well, we round to something that makes sense. In this case, all of our values are single-digit numbers, except for this one. It's a 2-digit number, but they are all integers. They're all they're all whole numbers. None of them are subdivided into 0.5 or 0.1 or anything like that. So since we're given this level of measurement here, we wouldn't round to 4 or 5 or 12 decimal places. It doesn't make sense. Taking it to 2 decimal places is something that statisticians do all the time for z-scores and things like that. If you're calculating a z-score using this standard deviation, you might want to take it to 4 or 5 decimal places, only because we don't want to lose any accuracy with rounding before the answer is given. So in general, you don't round until the end of the problem, but then at the end of the problem, you round to something that makes sense. If you're given no decimal places in your data, maybe take it to 2 decimal places in your statistics. If you're given a decimal place or 2 in the data, you might want to take it to 3 or 4 decimal places in the statistics. All right. The next question was question number, did I skip one? Number 3. Compute the mean and standard deviation of a sample presented in the following frequency table. Pause the video, try this out, and see if you get it right. All right, here in the frequency table, we're given that these different values of x are 1, 4, 7, and 10. We're given that the frequencies are 19, 5, 3, and 3. I know that the sum of all of these frequencies is 30. We're going to use that later. We do all the differences between each individual observation and the mean. We found the mean by taking all the individual values and multiplying by the frequency. So that's 1 times 19, 4 times 5, 7 times 3, 10 times 3, and getting 90. So that is all of the sum of all of the different observations here. We're going to divide that by 30 because there are 30 observations. The frequency total is 30. So we get 3. The mean is 3. Once we figured that out, we were able to do x minus x bar, in other words, 1 minus 3, 4 minus 3, 7 minus 3, etc. And we got our deviations. Now this deviation doesn't just happen once, it happens 19 times. So I'm going to need to take that deviation, eventually multiply it by f. But first I have to unnegative it. So remember, in the calculation for standard deviation, we square all these deviations so that they don't cancel each other out. They don't sum to 0. So all of these are squared, and then we take those squared deviations, a squared deviation, right, and multiply them by the frequency, because this deviation doesn't just happen once, this happens 19 times. So I multiply this number by 19, this number by 5, this number by 3, and this number by 3 as well. I add up all those deviations, the sum of all the squared deviations, and that's 276. Now I'm going to find the variance by taking all the sum of the squared deviations and dividing by the number of values, that's 9.2. And then remember the step when we squared, we have to undo that, so now we have to square root but in order to find the standard deviation. So 9.2 square rooted is 3.033, etc. Remember my suggestion to you earlier, if the data is given to us in integer form, we should probably round to at most 2 decimal places, and nothing else is going on down here that I would round to something else, so 3.03 is good enough. All right, moving on to the next question, question number 4. It's asking to classify variables by type and then by scale of measurement. Pause the video, try this out, and then see if you got it right. All right. Month was qualitative data. Qualitative because it's in word form, January, February, etc. It's on the ordinal scale because we can order them because August comes before September, etc., and so forth. For letter B, I should say, the year of birth is quantitative data. Quantitative meaning it is in numerical form that can be added, subtracted, etc. So once we figure out it's quantitative, we also have to say that it is discrete. Qualitative data, we don't tell whether it's discrete or continuous, but quantitative data we do. So it is discrete. In other words, you don't say 1950.5. You just say 1950 and then 1951. It's on the interval scale because the distance between values is consistent, like from 1950 to 1951 was 1 year. From 1951 to 1952, it's also 1 year. But fractions don't make sense. In other words, the year 2000 divided by the year 1000 is 2, but the year 2000 wasn't twice as long as 1000 or twice as big as 1000. It doesn't really make sense. For letter C, age, it's quantitative data. So if a person is 17, if a person is 34, those are numbers, numerical information that you can add, subtract, multiply, perform arithmetic to. So once we say it's quantitative, we also must state that it is continuous. It makes sense to say 17 and a half, like I am 17 and a half years old, whatever. But you cannot, I'm sorry, I don't want to finish that sentence because you can say 17.5. It's also on the ratio scale because fractions make sense. Like if I did 34 divided by 17, I'd get 2. A 34-year-old is twice as old as a 17-year-old. So that's why we use the ratio scale of measurement. Ratio scale also refers to the fact that absolute 0 matters. Like for example, with age, there is an absolute 0 that, when you're 0 years of age, you just got born or whatever. But you can't go below that. You can't reach an age that is less than 0. For zip codes, it is qualitative data. It's numerical, but it's not a number that you can add, subtract, multiply, or divide. Like if I took the, Forest Hill zip code, which is 11375, if I subtracted the zip code for, any other area in the world, it wouldn't make sense for me to do that. They're just labels. They're on the nominal scale because they don't represent an actual quantity or rank, so you can't put them in order. Like 11375 is not bigger or better than 11374. Moving on to question number 5. Question number 5 was actually a bonus question. It said it asks us to make a grouped data frequency distribution for problem number 1 using 6 classes. Now the number of classes is equal to k. We use that k value for the number of classes. So in order to find the class width, in other words, how many numbers to skip by, we take the range and divide it by k. The range here was 40 and 100, the difference between the smallest and the largest, which was 60. So we did 100 minus 40, which is 60, and then divided by 6, which is the number of classes that they asked us to use, and we got 10. Then we skipped by 10 from here on out. One thing that you should note is this was actually supposed to go from 90 to 99 if we were skipping by tens. However, there was a value of 100, so we had to say 90 plus, like 90 and all values above. You have to do that when your classes are not going to cover all of the values, and that'll only happen when your class width calculation gives you an exact number. Anytime you get a decimal number for this class width calculation, you are going to to go up to the next available number. That was the review on instructor exam number 1. Good luck studying.